So in this video, we're going to be looking at our final reaction when it comes to our alkenes. We're going to look at addition polymerization, which is different to condensation polymerization, because in condensation polymers, we actually take a carboxylic acid and we react it with either an alcohol or a amine to form a polyamide or a polyester. In this case, our monomer, our single repeating unit, is going to be an alkene for addition polymerization. Now, when we look at our polymers are going to be made up of long chains of these repeating units. Now, in this case, you can see I've got the alkene chloroethene, and of course, we end up with an addition reaction where we end up combining all of these alkenes together to make a long saturated chain. You can see here I've got polychloroethene being formed as a polymer. Now, if you were to look at our alkenes, we know that, of course, they're going to be unsaturated compounds. You can see I've got a carbon-carbon double bond, but when they react in an addition reaction, they actually become saturated, and so you can see my polymer, that carbon-carbon double bond, is no longer actually going to be there itself. So we know it's going to be saturated. If it's saturated, we know that these compounds, they're going to be chemically inert, and so they're not going to be biodegradable. We can also use the term non-biodegradable as a property for these as well. So moving on then, we need to be able to write equations for addition polymerization. And normally we take an alkene on the left hand side as a reactant. We take an n number of it, so that's the number of repeating units that we've got. And we get rid of the double bond. You can see over here there's no more double bond. And anything on carbon 1, we point it up and down as we have done over here. Anything on carbon 2, we point it up and down as we have done again over here. You can see it's just hydrogens in polyethene. And of course, we would need to put some trailing lines there as well. Now I also have some square brackets, not circular brackets, and you need to make sure that you've got n to show the number of repeating units, because that's going to be how many times you've got this pattern in your actual polymer. Now when it comes to certain exam questions, you could be asked to give either one repeating unit or more than one repeating unit. And basically over here you can see I've got the alkene again, ethene, and I've shown the same thing over here, carbon 1 and carbon 2. My trailing lines, the only thing that's missing is of course the letter n and then the square brackets. There's one repeating unit there. When it comes to drawing two repeating units, you're just going to take carbon 1, carbon 2, and then repeat the same pattern again to show two repeating units, with of course your trailing lines there as well. We're showing two repeating units of this polymer rather than one. You can also be asked to draw three, but of course that's the maximum that the examiner's asked for so far. So yeah, moving on then, I've got a task for you to do. Feel free to pause the video, have a go at the following question, and resume once you're ready to go over the answers. So looking at the first one then, we've got chloroethene that can be polymerized to form a polymer, and we need to give the equation for the actual reaction. So in that case, I'm going to end up drawing out a molecule of chloroethene as it is. I like to use displayed formula here, or semi-structural formula, that's fine as well, but you can use skeletal as well, but it's quite tricky. I'm going to have an arrow, a reaction arrow, and above this reaction arrow, I'm actually going to put addition polymerization to show the reaction take place. Now, of course, this comes up in 6 markers in terms of the level of detail that you need, and we need to get the reaction on there. So we've got addition polymerization above my reaction arrow. Now, of course, I'm going to move this so that it looks a bit neater. So I'm going to move my arrow so it's centered, and then I'm going to draw my repeating unit. Now looking at my product, I'm going to end up with, of course, my carbon-carbon single bond, because it's going to be saturated now. I'm going to end up with a long trailing line on either side. Attached to carbon 1, I've got chlorine. Attached to carbon 1, I've also got a hydrogen, and then 2 hydrogens for carbon 2 pointing up and down. Now just remember, when we're dealing with EZ isomers, we need to be able to show, of course, that EZ isomerism occurring in our polymer, because that pattern remains intact. I'll put some square brackets in, and I end up with something that looks like this. The only thing that's missing is I need to have an n over here to show the number of monomers that I'm using to form the number of repeating units in my polymer itself. And there's that one done. Looking at the next one, we've got a slightly tricky one over here. I've got here carbon bonded to another carbon. We can see the carbon-carbon double bond. There's carbon 1, carbon 2, and then we've got attached to carbon 1 2 chlorines. To carbon 2, we've got a hydrogen and a methyl group as well. Now, of course, we know this is going to be propene, but I like to just call it a methyl so it's easier to draw out. So yeah, if I look at this, I've got carbon-carbon, and it's going to be a double bond over here. Attached to the first carbon atom, I've got chlorines here as well, and then here I've got a CH3, and then I've got a hydrogen as well. Again, there's no EZ isomerism. It doesn't really matter which way you go about it. So yeah, I've got n number of repeating units. I'll do that first this time, and then of course we have an arrow with addition polymerization, so I end up with, of course, something that looks like this again. Now in terms of my product, I'm going to have my 2 carbon atoms laid out like this. Again, the double bond is gone. On the second one, we'll start off with, this time I've got CH3, and then we've got a hydrogen there, and then on the first one I've got 2 chlorines attached over here like this. I end up with some long trailing lines. I end up with, of course, some square brackets here, and then an N as well. And there's those two both done, right? Normally you get 1 to 2 marks for this. It is quite an easy question. But of course, they could actually ask you to give, let's say, the repeating units, the number of repeating units, which is what I want you to do. I want you to pause the video, have got the following task, and resume once you're ready to go over the answer. So looking at this question then, we're told that the alkene 1-bromo-prop-1-ene can be polymerized to form a polymer, and we need to draw 2 repeating units for this polymer. Now I would draw out the alkene first. So of course I've got here propene, I've got a methyl group attached, and then I've also got my bromine attached in the 1 position over here. I've got carbon 1, carbon 2. We can actually end up with EZ isomerism, but just remember, of course, when it comes to our E and our Z isomer, it needs to state it for us to of course include it in the actual polymer itself. Now of course I'm drawing 2 repeating units over here, so now I've got 2 carbon-carbon bonds, 2 carbon-carbon bonds like this, and they're going to be attached together like so. We've got carbon 1, carbon 2 in both cases, so there's carbon 1, carbon 2, carbon 1, carbon 2, and I'm actually going to have in carbon 1, I've got a bromine attached here, I've also got a hydrogen that I can't see, carbon 2, I've got a hydrogen that I can't see, and then I've also got a CH3 as well that of course we need to include on there. Now of course I'm going to end up with the carbon 1, I've got a bromine attached to the top, I'm going to put that on both cases. Same thing with a hydrogen attached to the bottom for carbon 1, and there's that part done. If I were to look at the next one, carbon 2, I've got a hydrogen at the top, and then on hydrogen 2 I've also got a CH3 at the bottom of that as well. And so you can see I've got 2 repeating units, and I need some trailing lines, and there's that one done. Looking at the next one then, we've got here, of course, 1, 2, 3 carbon atoms, structural formulas given to us in a bit of a weird way. And I'm going to draw out my structure to begin with. I've got an alkene over here. And then, of course, I've got 3 methyl groups attached to carbon 1, which I'm going to draw out like this. Now, if I look at this structure, I'm interested in, of course, carbon 1 and carbon 2 over here. If I were to draw 2 repeating units, again, I end up with 4 lots of carbon bonded together, some trailing lines as before. But in this case, we've actually got carbon 1 here, carbon 2 there. So I'm going to go backwards. You can go forwards as well if you want to, but I'm going to treat all of this as one group attached to one of the carbon atoms. So I'm going to end up with, of course, a hydrogen here. I'm going to end up with a hydrogen there, a missing hydrogen there as well. Let's start with carbon 1. I've got a hydrogen here, carbon 2. We're going to leave that. The other carbon 1, I've got 2 hydrogens again. And then let's look at carbon 2 now. Well, I've got a hydrogen pointing upwards in this case, so I'm going to keep it as that, keep it as it is. Now what's pointing downwards in this case? Well, we've already mentioned it. We've got C and then 3 lots of CH3. So I end up drawing that. I've got C and then I've got 3 lots of CH3, which should look like this. And then the same thing on here, C, and then 3 lots of CH3. Again, quite a hard one to draw for that structure there, but of course there's that one done as well. So moving on then, right, I've got another task for you to do where I want you to identify the original alkene monomer used to synthesize the following polymers. Again, pause the video, have a go, and resume once you're ready to go over the answer. So yeah, we look at the first one. We're trying to identify monomers, remember, and of course we've got here a repeating pattern that we can see. Of course we can see these 2 top terms there staying the same here, here, and here. So we know, of course, our alkene that's going to be used is carbon 1 and carbon 2 is there. I draw up my alkene carbon-carbon double bond. Attached to carbon 1, we've got a hydrogen here, and then I've also got a CH3 as well. Carbon 2, hydrogen, and then CH3 there as well, and there's that one done. Looking at our next one then, the bottom bit is staying the same, so we can't really tell anything from that. But looking at the top bit, we can see we've got hydrogen and then phenol, hydrogen and then phenol, so we've got benzene ring attached. Same thing over here again, same thing over here again. So I look at one segment, I redraw it out, so I've got carbon-carbon double bond. I've got, of course, a hydrogen over here, and then a hydrogen over here. One here, and then of course I've got a benzene ring, which of course you need to draw out like this as well. In some cases the examiner actually lets you get away with putting C6 and then H5, but of course we're not going to do that. We're going to focus on this one. So yeah, moving on then, that's how polymer is done in terms of the reactions and the skills that you need to be able to do in the exam. But we're about looking at reactivity, because we've already mentioned they're going to be saturated organic compounds. Well, addition polymers, we say they're unreactive because of that reason, and so we say that they're going to be non-biodegradable compared to our condensation polymers, which are biodegradable. Now, an advantage to this is that they're going to be long-lasting and reusable, but a disadvantage is that they're difficult to actually dispose of. Now, when it comes to disposing of them, there's 3 main ways that we can go about it. We can take the plastics and we can melt and remold it. If we can't do that, of course, we would of course crack it into monomers, and these monomers, these alkenes, they can be used as organic feedstock for other reactions. So basically just the reagents and reactants to do do other reactions in chemistry. Now, if let's say we can't actually do those two, we would actually just burn them. We don't actually practice this in this country, but I know many other countries do that. They actually burn it to release heat, and that heat's actually used to generate electricity. Now, all three of these processes are actually quite costly, and it involves sorting and processing, which costs a lot of money and time. And in a lot of cases in the UK anyway, we just resort to taking that plastic, that waste plastic, and putting it in landfill, which is quite bad because of course we know plastics, they're made from finite resources. So yeah, if we were to look at burning plastics in a bit more detail, we need to know that of course we burn plastics, that releases energy, but a problem is that sometimes toxic gases, they can actually be released, and these toxic gases normally come from chlorine containing alkenes, chlorine containing polymers like PVC. Now the actual toxic gas that's produced is going to be HCl, hydrogen chloride, and of course we know that dissolves in water, creates acid rain, and of course it's not that nice to breathe in as well, right? It contributes towards air pollution too. Now what we can do to get rid of this is we can pass it through a scrubber containing sodium hydrogen carbonate, that gas, and we pass it through sodium hydrogen carbonate mesh, and this actually neutralizes, right, and removes the HCl, making sodium chloride. So again, that sodium hydrogen carbonate is going to be a solid, and we pass that HCl gas, that toxic gas, over it, and we end up with, of course, neutralizing that HCl itself. An example that you need to be aware of is polychloroethene, and apply this to any other alkene that has, of course, a chlorine in it. But of course, polychloroethene, we look at the alkene for a combustion reaction, we need to remember the equation. We've got 2 lots of carbon, we've got 3 lots of hydrogen, and then a CO. And then, of course, we react that with, of course, oxygen. We end up producing 3 products, the common combustion products of carbon dioxide and water, but we also end up producing HCl as well. If we balance it, we've got CHO and then Cl in this case, and then we need to think, do the carbons balance? No, they don't. I put a 2 over here. Hydrogens, do they balance? Yes, they do. I've got 3 on each side. Oxygens, do they balance? Well, I've got 1 added to 4 on the right hand side, so I've got 5 over 2, that's 2.5 lots of oxygen. Chlorine, that balances, so that's fine. Now we also need to show an equation on how this is actually neutralized. So we take this HCl, this acid, and we react it with a base of sodium hydrogen carbonate, and we actually end up producing 3 products in this case: carbon dioxide, water, and then we also end up producing, of course, our salt, which is sodium chloride as well. And there's our 2 equations when it comes to, of course, the combustion of a chlorine containing polymer, and then of course our neutralization of the toxic gas being produced using sodium hydrogen carbonate. That one just balances on its own.